Hey guys, this is Miss Mo. Oh no, what happened? Okay, so we just did number 12. And let's go to number 13. 13 is a picture. It says limit as x approaches -3. So let me find when x is -3. X is the side to side. -3 goes left. 1, 2. Hey. Okay, so this is the important part of the picture that we're going to be looking at when x is -3. Okay, then the first one says -3 from the negative. That means left. So we're looking for the portion of the graph that's directly to the left. Well, you can barely see it, but it's this straight line side to side. So the first question is asking about the limit as we approach x of -3 from the left. So it's asking for what's the y value right here that's connected to this left side of the picture. Well, the y value is up 1, 2, so 2. Okay, now let's look at the next sucker. It says limit as x approaches -3 from plus. That means right. So this is my x value of -3, and I'm gonna look directly to the right of it, whatever is connected. I'm not gonna look way over here at this curve over here. I'm gonna look at just what's directly connected to it to its right. Okay, and this right-hand curve, when x is -3, the y value is still, we still land at the same spot. The y value is 2. Okay, now it says, what's the limit as x approaches just -3? Well, remember, when there's not a negative or a plus in the air, it means both. And the only way that we'll have an answer on this sucker is if the last two answers were exactly the same. And they were 2 and 2. So my limit is 2. Okay, then the last sucker says f of -3. Remember, that's talking about a closed hole. So we go to our picture when x is -3, this up and down line, and we look for the closed hole on this up and down line. And hot diggity, it's right here at, it looks like -3 up 4. Yeah. Okay, so we're gonna write down the y value as our answer. So f of -3 means if x is -3, what's the y value? And the y value is 4. So whenever you see that f business, it means you have to look for the closed hole. Okay, let's look at number 14. Number 14 says a bunch of symbols, but we know what these symbols mean, kind of. Okay, this first sucker says f of x bigger than 0 or greater than 0. Well, what is f of x? Is that x or is it y? F of x is y. So this is saying when y is greater than 0, or if you're having trouble with the alligators, this alligator means it means the y's are bigger than 0. So we're asking, when are the y values bigger than 0? Well, think about all your y values. 0 is right in the middle. Y values that are bigger are the ones on top of the graph. So let's find the portion of my picture that's on the top hemisphere. So this right-hand curve, this hump, not this little valley, but when it hits the x-axis and it humps up to a mountain and falls back to that x-axis, these are where the y is over 0, or the y is bigger than 0. There you go. So now we're going to write them in interval notation. Well, we have to know the x's for this. So let's find all the x's. This is an x value of 4. This one's 3. We already said 0 is in this inside. This one over here on the left is -1. And then I think there's a -4. Okay, so now we're going to describe these just using the x's. So this first purple piece that's above the x-axis, it's from the x value of -4 to -1. So let's write that with parentheses, -4 to -1. Then let's look at this next little mountain. His x values are from 0 to 3. Okay, so the interval is 0, 3. You might have to put a comma in between or U. I'm not for sure. Okay, then the right-hand portion, it looks like it starts at an x value of 4, but then goes to an arrow? What's the x value of this arrow? The x value of this arrow, since it's pointing up and to the right, the x is positive infinity. I know you really think that this arrow has an x value of 5, but it's gonna keep going that way. Okay, so the x values of this little portion is 4 all the way to infinity. And you don't need commas, but you do need U's. I just looked at your paper. We have to have U's. And remember that U is not the U from your keyboard. The U is the button on the screen. Okay, so now it says f of x less than 0. Well, less than 0 means smaller. So this is when y is bigger than 0. Crap, I wrote it wrong. Y is less than 0. And that means it's underneath the x-axis. So let's find when all the y values are underneath a 0. That means they're underneath this little hump down here, this little hump down here, and it looks like this little arrow over here. Okay, well, let's see here. Let's discuss the humps first. This first little baby hump, its x value goes from -1 to 0. Then a U, the next one goes from 3 to 4. The last one is this right-hand portion over here. And I know this x value right here is -4. When the arrow starts, it's -4. But eventually, this is going to go down and to the left forever. And if it's going to go to the left forever, the x value is going to be negative infinity. So because this is pointing down and to the left forever, eventually it's going to have an x value that's negative infinity. So my interval is negative infinity to -4. And we always use parentheses. So again, when it says f of x bigger than 0, that means it wants the top half. When it says f of x less than 0, it means the bottom part, the part that's underneath. Okay, let's look back at number 15. Number 15 says we got an equation. Here she is. We got a slope, exciting. We got an x value, woohoo. And then now, I think it asks for like the equation of the tangent line. Yeah, find the equation of the tangent line at this point. Okay, so the equation of the tangent line is gonna be y equals mx plus b. And I know the answer looks different, but you can write it my way too, and it will not count it wrong. The only way it'll count it wrong is if you did it wrong. Okay, so let's see here. My x value is 3, so I'm gonna put 3 there. My slope, that's my m, so I'm gonna put that where the m is, -3 over 98. That looks horrible. Plus b, and then now I need to figure out my y value. Well, they kind of told us, sort of. They gave us the x and the equation, so I can get a y by taking this x and plugging it into the equation. What? So if I want to find the y value, I'm going to take that x value, 3, and plug it into this equation. 1 over 5 plus 3 squared. And I think that makes 1 over 5 plus 9, 14. Okay, so that's the y value we're going to put up here in our equation. Okay, but then I want to get the b by itself so that I can throw it back in and finish the problem. So before I get b by itself, I'm going to multiply this negative 3 over 98. I use parentheses because I'm scared. Times 3. And I get something gross. You're supposed to press math, enter, enter. And I got negative 9 over 98. So we have 1 over 14 equals negative 9 over 98 plus b. And then get the b by itself. So to get rid of this dirty fraction with the 9s, the opposite of a minus is a plus. So I'm going to plus 9 over 98. Okay, so now I'm going to put this in my calculator because I'm paranoid. So I'm going to put that 1 over 14 in the calculator plus 9 over 98 in the calculator. It's going to be gross. We're going to press math, enter, enter. And I get 8 over 49 equals b. Okay, the very last step is to go into this y equals mx plus b and put a number where the m is and the b. So my very last step is to say y equals a number for the m. Where did we have m equals? M equals, m equals, m equals, m. M equals negative 3 over 98. Keep the letter x. And then that b, what was our b? B equals, b equals, b equals, b equals. Oh, b equals positive, so plus 8 over 49. And hey, that's the equation of the tangent line. I know it's not what the view and example says, but they will take this if you do it right. Okay, let's keep going. Number 16. Oh, this is just derivative stuff. Okay. And if you notice, I left out all those crazy equations about the secant line and the limit x plus h over h. You're welcome. Okay, back to this derivative. So first, before I can find the derivative of this, I need to kind of change it up using old school math. Remember, old school math says that the cube root is the same thing as a 1/3 exponent. And then remember that if something's in the bottom, I can take it up, but just use a negative exponent. So let's try this. So I'm not taking the derivative yet. I'm just rewriting y equals negative 11 x to the 1/3, but it's negative. So the 1/3 came from, it's a house. The negative on that 1/3 came from, it was in the bottom. And then it just slides up right next to that negative 11. Okay, let's take the derivative. To take the derivative, you take that exponent, you bring it down in front and multiply. So we get y equals negative 11 times negative 1/3 x to the, then you subtract 1 from the exponent. So let's see here, negative 1/3 and minus 1. And then this is a bunch of calculator or a bunch of fraction work, but I think you get, oh, my bad. We just took the derivative. So let me put a little tick mark on my y. Okay. Now, if you multiply this, these two suckers make positive 11 over 3. And then we get an x. And then let me do this negative 1/3 minus 1. Math, enter it. And I got negative 4 over 3. Okay, I'm not sure if, nope, this is good. We can take this as the answer. We don't have to put it back in a house. Huzzah, done with that problem. Okay, let's look at 17. It says a bunch of stuff, and in the past, it's been difficult, but it's not going to be difficult for us. Okay, first it says the derivative. Well, let's go. Take that 4, bring it down in front, and multiply. 3 times 4 is 12. X to the, subtract 1 from the exponent, 3. Keep going. Take that 3 in the air, bring it down and multiply it with the negative 12. 3 multiply negative 12 is negative 36. X to the, subtract 1 from the exponent, 2. Okay, then that 4 just goes away. All right, so this is our derivative. This is the answer to part A. Then it says, what is the slope when x equals 1? Well, this derivative is my slope. So all I have to do is plug in a 1. So let's see here. 12 times 1 cubed minus 36 times 1 squared. And that will be whatever my slope is. And don't forget to arrow out of the air so that you're not typing all in the air. But I got negative 34. Wait, did I do it wrong? Maybe I did it wrong. Oh, I did it wrong. I didn't put 12 at the front. Oh. Woo! Okay, negative 24. So that's the slope when x equals 1. Okay, so this is my slope. And what's the letter for slope? Slope is the letter M. So now let's go to this third one. It says equation of the tangent line at x equals 1. Okay, well, that's what we did up here. So we're going to plug in that slope of negative 24 into the M. We're going to plug in that x of 1 into the x. But we don't know what the y is. So let's find that real quick. Okay, so to find the y, we say plug in 1 into the OG, the original problem. So if I want to plug 1 into the OG, it's like f of 1, if you want to be fancy, of 3 times 1 to the 4th minus 12 times 1 to the 3rd plus 4. And I think that gives you 3, 1, negative 9 plus 5, negative 9 plus 4, negative 5. And this is our y value. Okay, so now we're going to plug it into y equals mx plus b. So we have y equals mx plus b. Our y value we just found was negative 5. My m we found in the second step. It was negative 24. My x is what they give us, x equals 1. And my b, we don't know it. Okay, so let's figure this out. We're going to get negative 5 equals negative 24 plus b. And then get b by itself. Add 24. And I think we get an awkward 19 or something. Yeah. Okay, so our final step is we're going to replace this letter M and this letter B into this equation, and that will be the equation of the tangent line. So we got y equals M, which was negative 24, x plus my b is 19. And hey, that's the answer to this third piece. So far we found the derivative, the slope, the equation of the tangent line. The last thing is to find this tangent line is horizontal. But first let me say A, B, C. Okay. To do the last one with that equation of the tangent line horizontal, okay, that means you take the OG and you put it in y equals, and then you look for when you have a number and 0 in your t-chart. So let's go to my OG equation. It's the very first one, 3x to the 4th minus 12. Okay, no, I didn't mean OG. I meant first derivative. Golly. My bad. Okay, so I want the tangent. I want to know when the tangent line is horizontal. So tangent lines come from all of this stuff, which comes from the slope or the derivative. So we're looking for when our tangent line is horizontal. So we're going to put our first derivative, because that's where we get slopes and tangent lines. We're going to put that sucker in y equals and look for a 0 in the y. So let's go to y equals, and we're going to put in our derivative. I said it wrong. Okay. Hey, derivative. Now go to your t-chart and look for a 0 in the y. I see 2 spots. I see 0, 0, 3, 0. Those should be my 2 answers. So y'all saw 0, 0 and 3, 0. So the last question said, when is the tangent line horizontal? Well, when x equals 0 and 3. Hey, that's part D. Okay, so part A, we took the derivative. Part B, we plugged that number into the derivative. Part C, we used that equation on the tangent line. Part D, we took the derivative and put it in y equals to find the x values that have a y value of 0. Woohoo! Okay, let's keep going. Number 18, it says C of x and R of x, but we want to know the marginal profit. Well, let's remember that marginal profit is everything you bring in, R of x, minus what it costs to make, C of x. So let me write down my R of x, 9x minus 0.01x squared, minus open parentheses. If you don't put this open parentheses, you will be wrong. And then I'll have to give you partial credit. Okay, so write down your R minus open parentheses. Now let's write down our C. And good gatos, if you do not distribute this negative, it's going to come out wrong. So make sure you distribute that negative. Write that down on your note card or whatever you get to use on your final. So we have 9x minus that 0.01x squared minus 239 minus 0.2x. So remember, this negative distributes and it changes everything. So negative times 239, negative 239. Negative multiply 0.2, negative 0.2. All right, let's combine like terms and put things in order. So the squared comes first. Then our x's come next. 9x minus 0.2x is, I think it's plus 8.8x. And then your naked number, minus 239. Okay, but this is just my profit equation. How do we find marginal? For marginal, we take the derivative. So let's take the derivative of this. We take this 2 in the air, we bring it down and multiply it in front. 2 times that negative 0.1. 2 times that negative 0.01. I get negative 0.02. X to the subtract 1 from the exponent makes a pretend 1, and I'm not going to write it. Plus, the derivative of a letter x is just that letter. Sorry, the derivative of a number and a plain old x is just that number. And then the derivative of 239 gets smashed away. So my marginal profit is negative 0.02x plus 8.8. So you had to use this formula, then you took the derivative. Okay, let's look at number 19. It says 10 years, 2.5% continuously. If we invest 10,000, what's A? Okay, well, this is that formula that looks like A equals PE to the RT. So they're looking for A, so I'm just going to leave it as capital A. P is what you put in. Well, if I invest $10,000, that's what money I put in. E is a button in your calculator. R is this decimal, but we have to change it because right now it's a percent. I can't put a percent in any math formula and get a correct answer from my calculator. I have to change this percent, so I'm going to move the decimal twice to the left, and you get 0.0259. So that's my R, and then my T is 10 years, so times 10. And then we just slap this in the calculator, and since we're talking about money, we're going to round like money. So 10,000, and then to get E, you press second, LN, 0.0259 times 10. And then we press enter, and we get 12,956.34. So 12,956 point, round like money, honey, 34. And hey, done with that one. Okay, let's look at part B. It says, how long will it take for this to grow to 25,000? Okay, so it's asking how long will it take? So how long is T? And we don't know it because they're asking it. So that's question mark. Then it says, will it take to grow the investment to 25,000? Well, on the last problem, I started out with 10,000 and it grew to 12,956, which was the A. So when it says when it grows to investment, or when the investment grows to 2,500, that means A. And then all of our other numbers are the same. So we're still going to use that A PERT formula. So let's go. A is 25,000 now. P is still the 10,000 that we invested from part A. E is a button in your calculator. R is still the 0.0259 that we used from part A. But this time, T, we don't know it. So put a T. Okay, now to get the T by itself, first we have to get rid of this 10,000, then the E, then the 0.0259. So we're just going to go super slow. First, let's get rid of the thing farthest away. So divide by 10,000. And we get 2.5 equals E to the 0.0259 T. Okay, good. Now, we're going to try and get rid of this E. The way to make an E cancel out is to put a L in. L in. Whoa. Okay, so when I put that L in, E, it cancels. The L in 2.5 does not cancel. That baby stays there. But the L in E crosses out. So L in 2.5 equals, and now what's in the air is big and normal, 0.0259 T. This reminds me of college algebra. Okay, then to get T by itself, well, it's multiplying with this decimale. So the opposite of multiplying with this decimale is to divide by the decimale. Okay, now we're going to put it in our calculator. And don't forget, the way we get L in is right here by the 4. So I'm going to type L in 2.5 close parentheses divided by that decimale. And I got 35.3. And we need to round to two decimal places. So I need more. Okay, 35.378. And we have to round to 2 decimal places. So that makes 35.3. The 8 makes the 7 go up to an 8. So we have T equals 35.38. So it said, how long will it take to grow that investment of $10,000 to $25,000? It'll take 35-ish years.